I'm at the, they call it Jiangnan Tianchi, so which is used to be the Asia's biggest and the world's second biggest pump hydro energy storage station. You know, we talked about the pump hydro a lot during our energy storage course. I never see one in person. Finally get a chance to see one in person. This one, 1.8 gigawatt of peak power generation capacity. So yeah, the rest you can see the introduction. I put it here. So that is the lower reservoir here. Remember this one? This is the upper reservoir. Yes, this one is the upper reservoir. That one is the lower reservoir. So yes, when there's excess electricity, pump water up, and when the grid has more load, discharge. This is an overview of the entire upper reservoir. Wow. This is a electromechanical room. This is the south dam, which holds the water. There are water inlets here. That building is a control building. Water inlets here from the upper reservoir. And up that side, I think it's a spillway. I can see a lot of valves. And there's a tube, like probably pipe, goes on to the top. I'm pretty curious what are those. What's this name? Upper Reservoir Transformer Station. So state grid is a power grid, and the number 1 of 2, like Upper Reservoir Transformer. Number 1 of 2. What the heck are these in? I cannot see anything from these windows. And here, can I see anything? There's a staircase. That's it. This is a gate. This is the main gate, I think. Yeah. So it's fenced, but there's a gate right down below our feet. That's a lift. I think the control rod is on the top. Oh, that's huge. The control rod is on the top, where the open and close the gate to release water. There's wow, cool. Upper reservoir water level measure. Wow. What could I say? Upper reservoir water level measure. There's a huge dense smoke right now. Sorry, fog right now. But that's where the water inlet is, I think. Yeah, it says no climbing. But obviously I need to go here. Oh, okay, yeah. So you can see the small check. That's a gate. That's definitely the gate. No, this is a gate. This is a gate. So water goes in from here. That's dammed, and there's another gate there, I think. Oh, so it's a symmetric design. Jesus, that's the symmetricity design, like in China. Wow. Yeah. So that's a. There's no spillway. I didn't see any spillway, honestly speaking. I thought there may be spillway. Maybe it does not need one. Upper reservoir gate number 2. So identical setup as the one there. There's the number 2 gate. There's number 1 gate there, number 2 gate here. Wow. Yeah, I saw these. I don't know what are they. Like, it looks like there's pipe inside. Maybe not. Number 59, and that's it. I don't think there's anything behind. Well, there is something behind. But nothing fancy. Some tanks, that's it. And symmetry to the south, water barrier wall, water barrier dam. This is the north water barrier dam. So pipe and rocks. Yeah, deep lake is dangerous. No climbing, no swimming. I can. Okay, I stick on it, but I can lean though. Yeah, that's the reservoir. So that's another part of the gate dam, and I can see the water level there. 2 measures of the water level. Wow. So this is a straight view of the entire upper reservoir. That's a gate. North dam, which you can see there's a dip there. Go flat, so that's a north dam. Far on the other side, you can see the dip there. Where the wall has a dip. That's a south barrier, south dam, and go all the way at law. I think they would be acted as spillways in case of emergency, in case of upper reservoir overflow. Well, it's easy, right? So they just close the entire scenery center if it's really that emergency. But normally this would not happen because I don't see any reason, like with very sophisticated control, it will stop. It will stop. It will overflow the upper reservoir. This is the entire model of the pump hydro station. You can see, like right now it's like this. It's discharging. So the hole at the bottom, the hole at the bottom there. Yeah, that one is the water inlet of the lower reservoir. So the lower reservoir itself is also a nature scenery. We probably will not go this time. So the hydropower station is actually not here. This is just a the discharge area. The hydropower station, they say, is somewhere here in the mountain body. So we need to walk in to see. And see that electrical tower there? That's a transmission line. So 500 kilovolt. And yeah, so it's discharging from the upper reservoir. We are right now at the upper reservoir, right outside. So this is the upper reservoir. So right now it's you can see discharge water. As we say, you can see this water discharging. We actually visited this place when there's fog on the top. So there's gate 1, gate 2, 2 gates with control room there. Yeah, that one is a control room. So this is the upper reservoir. So right now it's discharge. The entire reservoir's average depth is 42 meters with a deepest point of 72 meters. And the entire reservoir is wait a second. 姐姐，那个整个上水库的储量是多少立方米？885万。So it's 8.85 million meter cube of water. Yes. So right now it's discharged. The water level is low. I don't know why there's a car in the reservoir, but I think sure there's a lot of things in the reservoir. And that's the top of the temple, and here is the civic center, and you see these two. are the observatories we see on the way there. Yeah, that's a 80 centimeter Newton reflective telescope. So this entire project is actually managed by German company. They spent 6.2 billion Chinese yuan, and it has been paid back a long time ago. The entire project was constructed in 1992, took 8 years, and finished in 2000. Start commissioning in 2001. The overall efficiency of the system is 75%. Yeah. So as we are pump hydro experts, so we know about them very much. Pressure head tank 1. Here below, these two are actually also pressure head tank 2 and 3. Below, they just didn't put the model there. This is the entire station. We get the power on and we pump. So yeah, this is the entire model of how the water pump up. Transformer, the grid voltage is 500 kilovolt, feeding 1.8 megawatt to the transformers, and the transformer will just go to the spinning water turbine. Yes, the water turbine is exactly spinning to spin the water turbine. So the electric motor works as a pump, as a motor to drive the turbine, pump the water up all the way to the top reservoir. As we know, the gates here. And then when finish, when we want to discharge, we just stop pumping, start generating. Water comes below. You can see this one is trying to maintain the head. And coming down, the motor runs as a generator, spin in reverse. 18 kilovolt to 500 kilovolt feed out to the China East State Grid, and the lower reservoir is upper the water level. Let me see. Yeah, that's how the system works. So all I want to say is here, 18 kilovolt to 500 kilovolt, vice versa, 1.8 megawatt in 1.8 gigawatt in 6 turbines, so 300 megawatt each. Power off. This is the model of the entire water turbine / generator. I don't know what kind of turbine it is. It is called pump turbine. I will put a photo here. So the turbine, vertical shaft. I see sluice gates there. I see shaft gates here or sluice gates there, and the generator on the top. This is the model of the pump storage electro transformer station. So I don't know what it looks like. So yeah, okay, this is the high voltage side, 3-phase. That one probably is the low voltage side. 1, 2, 3, 4, 5, 6. So 6 transformer banks, which is identical to match 6 turbines. Wow. So okay. So and it's a dual channel, I think. So it's looped grid. And this one is okay. This is a transformer line. Jesus, that's huge. I think these are the gates or say disconnects. Wow. Many people think energy facilities, especially electrical energy facilities, may be ugly. But boy, I don't know how to say this. I feel this scenery is just amazing. And this is the upper reservoir. I don't know whether we will have chance to see the lower reservoir. If we have, I will include it in the video. If no, then Mark, Lucas, when you guys come, I will take you guys here for a tour.